We're going to take a look at how to prove lines are parallel given these different definitions and the diagram. So in order to prove lines are parallel, we have to know what the angles themselves are. So in this case, we're not told lines are parallel. We're told relationships between different angles, and we have to use those relationships to determine whether we can say the lines are parallel or not. So in this case, we've gone over all these different postulates: the corresponding angle postulate, alternate interior, alternate exterior, consecutive interior, perpendicular transversal. Going forwards, that's saying if I have two lines that are parallel cut by a transversal, this is the relationship of the angles. Today we're going to look at the converse of these postulates, meaning we are told the angle relationships and we have to say whether or not the angles are parallel. So again, corresponding angles are if we got two lines cut by a transversal and corresponding angles are congruent. Converse would be I have two corresponding angles that are congruent, therefore the lines are parallel. Same with alternate interior. If I have two parallel lines cut by a transversal, alternate interior angles are congruent. Going backwards, it's saying if I have two alternate interior angles that are congruent, the lines are therefore parallel. Same with alternate consecutive interior. If consecutive interior angles are supplementary, the lines are parallel. Alternate exterior angles, if they're congruent, then the lines are parallel. And then perpendicular transversal, if we got two lines perpendicular to the same line, then they are parallel to each other. So we're going to take a look at this first setup here. We have this following information. So we have 5 different pieces of information, and we have to say whether or not these lines are parallel. So our first example is angle 2 and angle 8. So I have to take a look. Can I say if A and B are parallel, or can I say L or M is parallel? In this case, we have 2 and 8 on opposite sides of line L on the insides of A and B. So in this case, 2 and 8 would be considered alternate interior angles for this particular section. So the two lines that get crossed by a transversal would be A and B. So in this case, we can say A is parallel to B. Now, the next one, we are asked to compare 1 and 15. So I have to take a look. Well, again, we can only have a situation where we're looking at the 8 angles around A, the 8 angles around B, the 8 angles around line L, or the 8 angles around line M. 1 and 15 do not have any immediate relationship, so therefore we cannot say anything regarding whether or not A and B are parallel or L and M. So in this case, no, we cannot say there is anything showing lines are parallel. Angles 3 and 11. So we have angle 3, angle 11. So I take a look here. We have 3 and 11 around line A. So 3 and 11, these are corresponding angles. They are on the same side of the lines. So they are on the right-hand side of line A. 3 is under line L. 11 is under line M. So because they are corresponding angles around here, the two lines that get crossed by line A as our transversal are line L being parallel to line M. And again, this is just kind of breaking down, seeing where the angles are. Next up, we have 8 and 6. So 8 and 6. In this case, we have vertical angles around line L. Because there is no real relationship, they're not corresponding, they're not alternate interior, they're not alternate exterior, we cannot say for sure that L and M or A and B are parallel because they are right on line L and right on line B. There's no relationship. So there's nothing we can say regarding parallel lines for this particular one. And then last but not least on this one, we are told 12 and 14. So 12, 14. So I want to look at this relationship because here we have 1 on the bottom left and 14 on the bottom right. So they are on opposite sides of line M, and they are on the outside of line A and B. So these would be alternate exterior angles, and we can use that to say that the two lines where they're being crossed, A being parallel to B in this case. So that is looking at angle relationships to see whether or not we have parallel lines. Number 2, we need to find angle MRQ such that line A is parallel to line B. So A and B being cut by the transversal, line C. We need to find this angle here at MRQ and this angle here, RPN, such that lines will be parallel. So I take a look. The angles are on opposite sides of line C. They're on the inside of lines A and B, so these would be considered alternate interior angles. And we know that for lines to be parallel, they have to be equal. So in this case, we're going to set our angles equal to each other. 5x plus 7 equals 7x minus 21, and we're going to solve for x. So we are going to subtract 5x from both sides. So we get 7 equals 2x minus 21. We'll add 21 to both sides. So that way they're solid numbers. 28 is equal to 2x. Divide by 2. So we get 14 equals x. So we need to find the angle MRQ. And MRQ is the 5x plus 7. Well, we just found x to be 14. So 5 times 14 plus 7. And 5 times 14 is going to be 70 plus 7, which gives me an angle measurement of 77. So that is using angle measurements to find angle such that it creates parallel lines. Now the next two is construction, so I'm actually going to make a different video because Kiami doesn't have a compass and a ruler to use it, so I'm going to make a second video for 3 and 4. But the first two problems using angle relationships to prove or show that we have two different sets of parallel lines.